Good morning. Nomenclature Part 4. This is our last lecture on nomenclature, and we're dealing with naming acids. All acids for our nomenclature purposes contain hydrogen, and the hydrogen is treated as an ion with a +1 charge. All acids will be in an aqueous solution, meaning they'll be in water, and that should be indicated by putting AQ after the formula as a subscript. So just an example of what it should look like when it's written properly, the formula. HClAQ, this is correct. This is a correct way to write an acid formula. HCl without the AQ is not correct. When naming acids, we will write the word acid after the name to indicate we have an acid. There are only two types of acids. There are binary acids and there are tertiary acids that we're going to be dealing with. Binary acids are acids that contain only two different atoms. If you recall that all acids contain hydrogen, then what's the other one? It's a nonmetal. Can there be very many binary acids? No, there can't be, because are we limited in our number of nonmetals that actually form acids? Yes, we are. In fact, all of the noble gases are not going to form acids, so that takes all of those away. Hydrogen is already taken away, so that leaves us fluorine, chlorine, bromine, iodine. Astatine is a metalloid. It's typically not going to make an acid that we're going to deal with. Same with tellurium. Same with selenium, although it's not a metalloid, but it typically does not make an acid that we deal with. Same with arsenic. Oxygen with hydrogen is water or hydrogen peroxide, so it will not make an acid. Basically, you're looking at fluoride, chloride, bromide, iodide, sulfide, phosphide, and nitride being the anions that will make acids. So that limits us tremendously on our binary acids. We'll come back to the periodic table in just a few minutes. We're going to balance the charges of the nonmetal ion and the hydrogen ion. Now remember, the nonmetal is going to be negative, the hydrogen is going to be +1. The big key to remembering the difference between binary and tertiary acids is the prefix hydro. If we have the prefix hydro, then it will be a binary acid. This is the only mention of hydrogen that we have. We will change the ending of the anion from "ide" to "ic." So our binary acids are going to be hydro something ic acid. This something is the nonmetal. So now you can actually name these without ever really worrying too much about them. We're doing binary acids, that's hydrogen and a nonmetal. So the name of this acid would be hydrofluoric acid. Try this one. Hydrochloric acid, hydrobromic acid, hydroiodic acid. This is the friendly acid. See if you can figure out why. Hydrosulfuric acid, hydronitric acid, hydrophosphoric acid. Please don't waste your time memorizing the names of those acids. Instead, just know how to name them. But I wanted to name all of them for you. Let's look at these examples. Hydrofluoric acid. How do I know that this is a binary acid? Because of hydro. So it's a binary acid. That means it's going to be a nonmetal plus hydrogen. What's the nonmetal? Fluoride. Then we go backwards and we say, what's the charge of hydrogen? +1. What's the charge of fluoride? -1. They're balanced. AQ, we have the name of the acid as well as the formula. Hydrophosphoric acid, again, it is binary because of hydro. It's going to contain hydrogen and phosphide because it's a nonmetal. So that's hydrogen and phosphide. What is phosphide's charge? -3, that means I need 3 hydrogens, AQ. Notice, never put charges in formulas. I don't know that I've said that in this series, but we never put charges in formulas. If the formula is written for us, then yes, we can put the charges. But in a final answer that we write, you never put charges. So let's look at this example. I have only 2 elements. 2 elements mean binary. That's what we know, which means hydro. And then this sulfide changes into, and it is actually sulfuric. If you wrote hydrosulfic, I would count it correct because you might not know the difference. But the true answer is hydrosulfuric acid. Hydrosulfuric acid. HBr, AQ. Again, binary acid. So we're going to say hydro. This is bromide, so it changes to bromic. Hydrobromic acid. One last time, I want to go to the periodic table and look at these. Hydrofluoric, hydrochloric, hydrobromic, hydroiodic. What are the formulas for these? HFAQ, HClAQ, HBrAQ, HIAQ. Do you know now why that's the friendly acid? Why do I only have one H in all of these? Because their charge is -1 and hydrogen's +1. Hydrosulfuric would be H2S AQ, again a -2 for sulfide, +1 for hydrogen, that's the H2S. H3N is hydronitric because of +1 for hydrogen, -3 for nitride. Hydrophosphoric is H3P AQ. Please don't memorize these acid names. Learn how to do them. Tertiary acids is the other type of acid that we want to name and write formulas for. Tertiary indicates 3 or more different atoms. These also contain hydrogen. Why? Because all acids contain hydrogen, and these will contain a polyatomic ion. So in these acids, we actually will have the hydrogen as always that an acid contains, but we're dealing with polyatomic ions. This opens up a lot of possibilities for us in our acids because we have a lot of polyatomic ions that we've learned. Once again, you balance the charges of the polyatomic ion and the hydrogen ion, remembering hydrogen is +1. Big difference though. You do not use the prefix hydro. Do not mention hydrogen at all in a tertiary acid. It is understood that hydrogen is present because all acids contain hydrogen. However, you do not mention hydrogen. The way you know the difference between tertiary acids and binary acids is because binary acids do say hydro. Tertiary acids do not say hydro. You realize already that there are different endings for polyatomic ions. The polyatomic ions have 8 and ite endings. That is also going to be true for our tertiary acids. It's those endings that will tell us which polyatomic ion is present. Here's the way to remember that. If the original ending is 8 for the polyatomic ion, you're going to change the ending to ic. If the original ending is ite, you will change it to us. A goofy reminder is to think of the tertiary acids as having the disease aitic-itis. Just like arthritis and gastritis, all of those itis diseases. Well, think of the acids as having aitic-itis. That means the 8 endings change to ic, the ite endings change to us. We can go to our polyatomic ion list and actually name all of these acids to begin with. So let's do that. I want you to hear the names of these. Hydrogen with hydroxide is going to make water, so that's not going to be an acid. Acetate would become acetic acid. What would go in front is 1H, because these all have a -1 charge. So it would be acetic acid would be HC2H3O2. Permanganate would be permanganic acid. Iodate would be iodic acid. Cyanide will not make an acid, but cyanate will make cyanic acid, thiocyanic acid, nitric acid, nitrous acid. Remember the ate, ick, ite, us. So nitrate becomes nitric acid. Nitrite becomes nitrous acid. Perchlorate becomes perchloric acid. This would be chloric acid, chlorous acid, hypochlorous acid. Carbonate would become carbonic acid. This is the acid that is in all carbonated beverages, because carbonated beverages contain carbon dioxide bubbled through water, which makes carbonic acid. Chromate, chromic acid. Dichromate, dichromic acid. Oxalate is oxalic acid. At this point, most students say, she is just making these up. No, I'm not. Go to the cleaner aisle at Walmart or your supermarket. Find a cleanser called Barkeeper's Friend. It is a stainless steel cleanser. It's a powdered cleanser. And look at the little canister and you will see that it contains oxalic acid. Oxalic acid will clean rust. Silicate is silicic acid. Peroxide and hydrogen would make hydrogen peroxide, so that's not an acid. Sulfate becomes sulfuric acid. Sulfite becomes sulfurous acid. How many hydrogens would have been with all of those? 2, because of the -2 charge. Arsenate will become arsenic acid, arsenous acid, phosphoric acid, phosphorus acid. Look at your Dr. Pepper bottle and you will see that phosphoric acid is in Dr. Pepper. Let's try it. How do I do this? Well, I know it's an acid. How do I know it's an acid? Because it contains hydrogen and it's AQ. What is the name of this polyatomic ion? It is acetate. So the name is acetic acid, because 8 changes to ic, and I do not say hydro. Acetic acid. By the way, this is vinegar in your house. H2SO4AQ, again, it's a tertiary acid, so I do not say hydro. What is this polyatomic ion? It is sulfate. 8-ic. Again, if you put sulfic acid, I would count it correct, but it is in fact sulfuric acid. And this is battery acid. This is the acid found in your car battery. Sulfuric acid. Now, I will point out, if I were to give you these 2 examples on a test or quiz, and you put battery acid, it would be incorrect, because the proper name is sulfuric acid. H2SO3. I jokingly say this is the name of the acid when you're really mad and you are from Kentucky. What is sulfite? Oh, I've told you the answer. SO3 is sulfite. Sulfite changes to us. The ite changes to us, and it's actually sulfurous acid. Have you ever been sulfurous? You didn't know what to do? That would be very angry. Carbonic acid, we're going backwards now. Carbonic came from carbonate. It has a -2 charge. That means I need 2 hydrogens. AQ. Hypochlorous acid. Do not get hypo mixed up with hydro. This is hypochlorous, coming from a polyatomic ion called hypochlorite, which is ClO. It has a -1 charge, so I need 1 hydrogen, AQ.